Good morning, everyone. Today I'm going to represent you a review named Source Separation for a More Sustainable Environment on behalf of Nursel İpekoğlu, İlhan Tadın and me. What you are going to see in my presentation is first aim of the study, then sustainable water system, then how to obtain more sustainable wastewater treatment system, separating household wastewater. In that separating household wastewater, we are going to see separating urine from the household wastewater as yellow water, its benefits, disadvantages, and risks, and what has been done up to now to overcome the disadvantages and risks, and finally the conclusions. Now, what's the aim of this presentation? Up to now, you see lots of research papers, but what you are going to see is a review. Because we did lots of research and we combined them right now with other researchers from other countries. Aim of this presentation is to introduce the source separation of domestic wastewater, to discuss urine separation or yellow water separation as a more sustainable wastewater management option, and to summarize what has been done to overcome the disadvantages and risks. Now, everybody knows that the traditional aim of the conventional wastewater treatment system is to enable wastewater to be disposed safely without being a danger to public health. But we want more right now. And what we want to recover energy, we want to recover the nutrients, we want to recover water and other valuable resources from wastewater. Is it possible? We want everything, but we cannot get everything at the same time. So sometimes yes, sometimes no. It depends on the treatment system or the technology we use. And we know that wastewater treatment, like energy systems, is conventional centralized or decentralized systems. But why do we want to recover energy or nutrients and water? Because we know that we have to achieve sustainable development, which we hear in recent years. And the definition of sustainable development is so clear, and it is defined in 1980-70 as development that meets the needs of the present generation without compromising the ability of future generations to meet their own needs. But I don't like this definition. What I like is all individuals have equal rights, whether living today or in future. So we have to think together, economy, environment, and well-being together. And it results the three main characters of sustainability, which is economic, environmental, and social cultural. And in the previous presentation, you heard about the indicators that we look for the sustainability, so I'm just passing it very quickly. For economical indicators, we can think about cost and labor, environmental indicators, resource utilization or reuse, sludge waste production, use of chemicals, accumulation, biodiversity, land area required, emissions, pathogen removal, and so on. We can add lots of. And social cultural indicators is the social acceptance, local development, participation, and we can also add more. But finally, we come up with some sustainable water system should be a smart system. And the smart system must think of energy, can be generation or recovery, and nutrient recovery surely, and water reuse. Can we obtain it? It's not so easy, but we can obtain a more sustainable solution. And how can we obtain it? If we just decrease the amount of clean water which we use as flash water, and nutrients are recovered with higher efficiency. If cost of the technology is lowered. If the technology used for treating and recovering the wastewater has a long lifetime, means the technology should have a long lifetime, the amount of sludge is reduced and the amount of byproducts, which is biogas, biomass, compost, is maximized because it's used for energy recovery or energy production. So how can we achieve this? If we can use or if we can find a system that minimizes the cost, that minimizes the energy consumption, that minimizes the land area while maximizing the performance, then we have a more sustainable wastewater treatment system. Small decentralized systems can be a good option for that. In the picture you can see the sources of household wastewater, and in that part you see black water, which is a toilet water combining of feces and urine, and you see gray water, which is the combination of the kitchen sink, dishwasher, bath shower, clothes washer, and the other stuff, and also storm water. Why do we want to separate them? The important thing is that because if we separate them, it gives us a chance to reduce the eutrophication, and we can recover the nutrients and use them instead of the mineral fertilizers. And we can decrease the amount of fresh water that we use for flushing, and we surely save energy. You can ask yourself why urine, because it's nothing inside you can think of, because 95% of it is water actually. But human urine is the largest contributor of nutrients to household wastewater if you don't dilute it with other fractions. So 80% of nitrogen and 50% of phosphorus from domestic wastewater at treatment plants is contained in urine. And most of it, as I told you, is water. The rest is urea, sodium, potassium, sulfates, calcium, magnesium, and so on. But we have also nutrients in feces, but it is not available for us, available for plants. And also it has a pathogenic bacteria that we cannot use very safely. How do we separate urine from the household water and collect? As you see, we have two examples here. One is Sweden research studies, the other is Swiss research studies, because we know that this kind of source separation technique is much more developed in Sweden, in Germany, in Switzerland, and right now most of the researchers use the first one, the Sweden research. This one, no-mix toilets. What are those no-mix toilets? These toilets have two bowls, one for the feces, one for the urine. And once the urine is separated in the toilets without contracting with each other, it passes through a separate pipe and the holding tank, which is connected to more households like this. And after the collection, you can also transport it by trucks or suction truck to storage for the other storage tanks. For the Swiss research studies, it's much more difficult because they want to use their existing pipeline system. So what they do is they are trying to find the time where the conventional treatment system's load is too low, and they just use that pipeline to transport the urine which is collected. We have lots of difficulties and risks. The first difficulty is using the toilet, because it definitely has two bowls, but the children, what we see, children and older people cannot use this. And but several things have done up to now, and it's getting much more better. And the second one is difficulties in storage. And by the way, the first difficulty about using the toilets is also the toilets, the previous toilets use higher amounts of flash water, but the new ones use lower. Difficulties in storage. As I showed you, urine is 95% of water, but the other is urea. And urea is decomposed, hydrolyzed to ammonia. And as the pH increases, most of the magnesium ammonium phosphate and calcium oxalates are precipitated in the storage tank itself, and it clogs the devices and the pipe entrances. This is the main problem. The other difficulty is the transportation, just because of this reason again. Difficulties in farmland application. In the previous slide, you saw that in Sweden they are using the urine in farmlands. Means that they are just using the nitrogen and phosphorus in the urine as it received. But we have lots of problems in the application, during the application. The risk is the pathogenic bacteria transmission due to wrong usage of the toilets, because once they are mixed, then we have the risk of pathogenic bacteria transmission. And the risk of pharmaceutical and hormonal residues transmission, this is because of the pharmaceutical residues that are found in urine and that might be transported to plants if we have to use it in the agriculture. Now, what we have done lots of things, but I will say country by country. In Sweden, in Swiss research, they tried to reduce the volume of urine, because you know that the volume of as the volume of the urine increases, the volume of the tank increases. So what they want to do is to reduce the volume of the urine. The first technology they tried is freezing, and nearly 80% of nitrogen and phosphorus was concentrated in 25% of the volume. Again, Swiss researchers think about to recover the nitrogen, but right now with the evaporation, not with the other option, not the concentration. Evaporation of non-hydrolyzed urine, but obviously it is nothing, it is not a way that we want, because we are using here energy. It's done in 78 degrees C and at 200 millibars. But you have viscose solution of 10% of nitrogen concentrated. And another research in Sweden, they reduced the ammonia evaporation by acidification. They tried sulfuric acid, acetic acid, and hydrochloric acid, and ammonia evaporation was reduced. This is because of the chemistry of ammonia evaporation, we know. And acidification was found to be a useful method when sulfuric acid is used, and also they also tried freezing, and again addition of thymol and hydrochloric acid, and it was seen that the urine is stable for 7 days if thymol or hydrochloric acid is used. And to reduce the risks, the Sweden researchers searched for the storing the urine at low temperatures around 4 degrees C, and they found that the infections, the infections which can come from the rotavirus is acceptable. Risks are acceptable in unstored or stored at low temperature, if stored at lower temperature, sorry. To recover phosphorus and nitrogen in source-separated urine, this is what we did in Turkey. We precipitated magnesium ammonium phosphate hexahydride, and we have 98% of phosphate recovery and 40% of nitrogen recovery, ammonia nitrogen recovery, and the optimum reaction pH was not so high, around 9.5. To eliminate the contamination of separated human urine with feces, as I told you, because of the toilet usage, and to decrease the clean water consumption, Sweden researchers designed different types of toilets. With the different designs, 50% of the flush water was saved when compared with conventional toilets. To understand the precipitation potential of urine in pipes during the transportation, Swiss researchers applied a simulation program and to simulate the precipitation during the transportation. And also in Turkey, what we did is to strip ammonia with air into sulfuric acid to obtain ammonium sulfate, which is also fertilizer. And other studies relating with the transportation is the studies on existing sewer network, which is done by the Swiss researchers. To recover the urea in urine, also Denmark, researchers from Denmark precipitated isobutylaldehyde urea, and they have very high recoveries in unhydrolyzed urine. To recover nitrogen again, Sweden researchers also did the precipitation of magnesium ammonium phosphate hexahydride, but as you see, we have 40% of nitrogen recovery in that process. What they did is to add adsorption with WASTEnet and zeolite to make it 65 and 80% of nitrogen recovery. To investigate the different uses of separately collected human urine, many researchers from United States did the culturing of green algae, which is important right now because of the hydrogen production. To investigate the social acceptance of urine-based fertilizer, lots of surveys have done up to now, but in Swiss it is much more, let's say, detailed, and the result is the whole concept of urine separation is accepted only if the comfort of living and the expenses of the new technology are same as conventional ones. And also to evaluate the potential use of urine in aquaculture systems, toxicology tests were done with, by the Sweden researchers, Daphnia magna, they used, and they saw that the supernatant of magnesium ammonium phosphate hexahydride, if you precipitate it, or if you don't precipitate it, doesn't matter. If you use the stored urine directly, they're highly toxic to Daphnia magna. Also, benefits and drawbacks of urine separation systems is investigated by a simulation program which is developed by Sweden researchers, also is Orware, and also they applied this system to an ecological village and also gained the results and compared them with Orware. In Turkey, we did research with the possible interaction of tetracycline with steroid. Tetracycline is an antibiotic which passes to urine in very high amounts, and we searched for adsorption and co-precipitation performance of tetracycline. And we saw that around 17 or 22% of tetracycline is precipitated with magnesium ammonium hexahydride, phosphate hexahydride. And to compare the wastewater treatment and urine separation, life cycle assessment studies are done right now. and have been done in before, but right now we have lots of conclusions and results. Now the system is much more fed with the results. To understand the public acceptance in United States, there are many surveys right now. They are right now done by the researchers in Hawaii, and the surveys are different from the Swiss approach. And in the United States, they are willing to pay if it is ecological, if they see if it is ecological. Now, for conclusions, as you see, urine source separation is still very immature, so we have to do lots of things to make it much more better. And suitability of different approaches should be investigated. As I told you, this is a kind of a review combining lots of studies. So I add here list of references because you know that this conference is going to be in YouTube and in our websites. You can find the references in here if you want to read more. And also you can contact me from my email. Thank you for your attention and for your listening.
Questions?